We can use simple if statements in MATLAB to run code only when the results of a logical test are determined to be true. Let's take a look at the syntax for a simple if statement. In MATLAB, we start with the keyword if, then we put a space, then we use something called a logical scalar, or a condition that results in either a true or false evaluation. True are encoded as ones, and false are encoded as zeros. In between the word if and the word and, we call everything in that space the body of our if statement. That block of code can include any executable programming statements. Moreover, the only way that we will actually execute the code in this body of the statement is if the condition that defines our logical scalar is determined to be true. If that condition is false, we actually skip all code in the body and go on to the next statement outside of our word end. All if statements start with the word if, terminate with the word end. Everything between that is known as the body of our if statement. Our first example is going to focus on a check to see if a stored number is equal to 1 or 0. Remember way back when we had this function called randi, which is a random integer. The first argument of that function was the maximum upper bound for the integer set. So specifically, if I type randi of 2, MATLAB will produce a random integer that is either equal to 1 or 2, uniformly distributed. So specifically, we could actually look at randi. Let's say the upper bound is 2, and let's call this a 1 by 8 vector. Notice that some of those are 1 and some of those are 2, and that's a pseudo-random integer generator. So I could actually define a variable num, and we'll call that equal to randi of 2, and let's subtract 1 from it. Remember, if randi of 2 is evaluated as 2, if we subtract 1 from that, that's going to get 1. The other situation, if randi evaluates at 1 and we subtract 1, that will be 0. So the variable num in terms of number will either be equal to 0 or 1. Before we actually write our if statement, let's go ahead and check that that's true. Sometimes it's 1, sometimes it's 0. Notice we'll never get outside of that because of the way that that randi function behaves. Now we're going to use a simple if statement to write some code that only runs when the value of our num variable is set to 1. To do that, let's go ahead and start with our syntax. We type the word if, we put a space. Now we need a logical scalar. In this case, we're going to use a logical operation. We're going to say, please check to see if num is equal to 1. I always recommend writing end as soon as we finished the first line of our if statement. That way they're grouped together. Notice MATLAB automatically puts this grouping symbol, which is kind of nice. Once we've done that, let's go back into the body of our if statement, and we'll actually go ahead and display a message to our user that says, you got 1. Yay! As soon as I push run, MATLAB actually ran one by one through the lines of code sequentially. First, it recognized this as a comment. Then it moved down to line 2. It initiated the number variable by calling the randi function. It subtracted 1. Notice that I can actually check what that value was. It was 0. Then MATLAB actually tested, is num equal 1? Let's go ahead and look at that. Num equal 1. That ends up to be logical 0. That line of code ended up to be false. The moment that the logical scalar turns to be false, MATLAB actually skips the body of the loop and continues down after the end statement. In this simple line of code, I have nothing after the end, and so MATLAB stopped the execution. But the point of the matter was, in this simple test, the logical scalar evaluated as 0, and so we did not display the message to our user inside the body of the loop. Let's run this one more time and see if we get one. Check this out. MATLAB did the same thing, initiated the value of num. We can actually check what that value is based on that run. In this case, num was 1. MATLAB drops down to the if statement. It checks, is num equal to 1? We'll go ahead and look at that logical scalar. In fact, in this case, num is exactly equal to 1. So this logical scalar evaluates as true. The moment that MATLAB verifies that, it will actually drop into the body of the loop and execute this line of code only under that condition. When we look back up, that is exactly what happened here. MATLAB executed the line of code when the value of num was 1, whereas in our previous run, it did not execute because the value of num was not equal to 1. Let's move on to a second example that highlights a very common common use of if statements for what we call error checking. Very often when we're writing code, we want to make sure that the inputs to a specific function or routine satisfy some condition. In this case, we're going to pretend that we want to check to make sure that a variable is a scalar. Because this is a script file, I don't want all of my code to be run, so I'm going to just go ahead and comment that top code out. One thing that I will say is I titled this script file Simple If Statement Sandbox. When I am testing code to put into a project, I often create a sandbox file where I run simple tests and work out the kinks, and then I'll copy and paste from the sandbox into a more permanent structure, which is the project that I'm working on. In any case, let's go on to example 2. We'll create a variable. In this case, we'll call that variable 4. Then what we want to do is create a simple if statement to check whether or not 4 is indeed a scalar valued variable. To do this, we'll use our syntax that we saw for our if statement. We'll type the letters if. Then we're going to type a logical scalar. This logical scalar is going to be a test to see if the variable x is a scalar. Remember in a previous video, we actually had a function called isScalar to do exactly that. So specifically, if I type isScalar x, that function is going to return a logical 1 when x is a scalar and a logical 0 when x is not a scalar. Now that I have that first line, I'm going to push return, return, and write the word end. That gives me the start and end of my if statement. Let's drop into the body of our if statement and we'll produce a simple message when this evaluates to be true using the fprintf function. Specifically, we will say, great, this variable is a scalar. Notice in this case, we've initialized x to be a scalar. So we would expect when we run this that isScalar produces a logical 1, and thus we should get the following message to print out in the command window. Let's go ahead and run this. When I push run, the first thing MATLAB does is start at the first line. It recognizes all of this code as comments, drops down to line 8, initialize the variable x to equal to 4. Then it goes into the if statement. The moment that it says if, it checks the logical value of this logical scalar. This is a 1-by-1 logical array stored using the logical data class that either has value 1, in which case that statement is true, or 0, in which case that statement is false. Well, notice in memory we had x was 4. If we type isScalar x, this returns logical 1. In this case, MATLAB confirmed that the variable x is indeed a scalar. The moment that that logical scalar returns a true statement, MATLAB drops into the body of the if statement and actually executes all lines of code that are found there. And that is exactly why we see this output. Great, this variable is a scalar. Let's go ahead and test when this doesn't happen. Let's create a vector value for x. Maybe we say it's 3, 4, 5. That's a row vector. Now let's rerun this code. When we do that, notice MATLAB does not produce our message because specifically x is now a row vector. If I do isScalar of x, that produces a logical 0. The moment that the logical scalar or the condition of our if statement evaluates at 0, MATLAB jumps over all code inside the body and moves to the next line of code that is found after the end. In this simple example, we don't have any other code, and so we stop running this script file. I will note that we can actually use logical operations to define this condition. Sometimes we will be writing functions where we want at least one of the inputs to be a scalar, and we might actually include some error checking to produce an error message if the user input a value that was not a scalar. To do that, all we need to do is let's test that this is not a scalar, and then we'll create a message that evaluates, oops, error, this variable is not a scalar. We'll stop execution of our program because we've actually passed in a variable that does not match the expectation that we have. Notice that this condition, this logical scalar, will evaluate as true only when x is not a scalar. Let's go ahead and test this. X is a row vector, so we would expect that isScalar gets 1. Not isScalar gets 0, so we would actually expect if we run this script file again that we drop into the body of the loop. This fprintf will print out in the command window, and then the return actually terminates all execution and pops back into the command window. In other words, if the body is triggered, MATLAB would stop all execution right at that moment, giving the user an idea that something went wrong in the code. Let's go ahead and run this and test. Notice MATLAB did produce, oops, error, this variable is not a scalar. Once again, we can test if we go back to the value maybe of 3, x is now a scalar. isScalar produces 1, not is scalar produces 0, so we do not expect this to run for this value of x, and indeed when we push run, no string is produced because MATLAB saw that this logical scalar had value 0 and simply skipped over the entire body, going back past the end statement. One useful way to visualize the logical and organizational flow of an if statement is using a flowchart. Remember, in flowcharts we use a diamond for a decision-making process and a box for a standard line of code. So the logical flow of this if statement is we go into the if statement and we test the logical scalar or the condition right after the word if. If that condition is determined to be true, we actually jump into the body of the statement and execute any lines of code. Then we drop after the end statement and keep going. On the other hand, if the logical scalar evaluates at 0, in other words, the condition is determined to be false, we actually skip over the body of the if statement completely, drop past the end, and then keep going to all lines of code after it. This is why we call this a branching statement, because we actually have a branch away from sequential processing into different options depending on what decision we make. Remember, in sequential flow, we go from one line of code down to the next. Each line of code gets run once, and no line of code is skipped. We're not jumping around. But in a branching statement, we actually do branch to different options depending on what decision we've made about the condition that we're testing. Let's look at yet a third example. In this case, we're going to write a test to figure out whether or not a variable is a non-scalar vector. In other words, either a row vector or column vectors that has more than one entry. To do this, I'm actually going to use a practice that I do when I'm in my sandbox files. I'm going to comment out code that I've either already tested or integrated and keep that at the bottom of my file. All the new code that I want to write, I'm going to keep at the top of my sandbox, since that's the thing that I want to focus on and I don't want to scroll back and forth. So in this case, we'll initialize a variable to be 3, and we'll write an if statement. In this case, we're going to test, is the variable y a vector? Here we're using the isVector function that returns a 1 when y is a vector. Then we'll drop down and end that if statement. In the case that the condition is determined to be true, we'll go ahead and print out a message that says, you found a vector. Let's run this code to test it. Notice when we run this, oh my God, MATLAB is telling me that y equals 3 is a vector. Let's go ahead and test that. Is vector y indeed produces a logical 1? In other words, this is true. And that is because all scalars are vectors, but not all vectors are scalars. Remember, this is a test for a non-scalar vector. So we need to test not only is y a vector, but we also want y not to be a scalar. So specifically, we're going to write not is scalar y. This is exactly why we spend so much time on logical operations, so that we can combine those together to actually produce the type of error checking that we want. So in this case, I'm going to test two different things need to be true at the same time. Number one, y needs to be a vector, and simultaneously, y cannot be a scalar. Moreover, we'll make sure to be very, very clear that the not operation is testing the is scalar, and then after that is done, we want to combine that with an and is vector. Now when we run this code, we would expect that that message does not happen because y is a scalar. So is scalar evaluates as true. Not is scalar evaluates as false. This is an and. In order for ands to be true, both the left and the right operand needs to be true. So in other words, this entire condition, this logical scalar evaluates as false. MATLAB skips the body and moves on to the next line of code. On the other hand, if we use colon notation to define a 5x1 column vector, notice when I actually run this thing, MATLAB will produce you found a vector because y is a column vector. In other words, is scalar of y turns out to be false. Not is scalar turns out to be true. Is vector is true, so this is true and true. The entire logical scalar is true. The condition in our if statement is met. We drop into the body, produce that line of code. When that's done, we drop out of the end and move on. That's exactly what's happening in this flowchart. The condition of the if statement was true. We drop into the body, execute all lines of code that are found. When that's done, we go after the end and continue on in our flow. Let's take a look at yet a fourth example where we prompt the user to input the letters Y for yes or N for no, and then run specific code when the user gives us a yes response. To do that, we're going to use the function input from MATLAB's built-in function library. Let's go down to the command window and type help input. Notice this function prompts the user for input. the syntax looks something like result equals input open prompt. When we run that, that displays the prompt string on the screen, waits for input from the keyboard, evaluates any expressions in the input, and then returns the value to result. Moreover, if we just scroll down just a little bit, check this line of code out. When I say str, could you guess that means string? That's a type of MATLAB variable. Get input of parentheses prompt comma quote s quote, that returns the enter test without evaluating the expression. So one thing you see up here is if I just run input prompt and then the user inputs a value, MATLAB will determine that that is a line of code and then evaluate it appropriately. But if I want to accept text as string, then I can use this second parameter to my input function so that I can collect input from the user as a string or as text rather than to evaluate it itself. Notice also to create a prompt that spans several lines, we can use \n to indicate each new line. Let's go ahead and write some code that does that. That's exactly what I've done here. I'm going to define a prompt, which is going to be using the character data class in MATLAB. Remember, characters are determined with single quotation marks. So here I'm going to ask the user, please choose Y or N. Let's go ahead and do a colon and then go down to the next line in my command window. That's exactly what my documentation is telling me I can do. Then we'll say user choice. So this variable is USR underscore choice. That's the choice that my user makes. And we're going to say that becomes the value returned by the input function. Here, the input is going to display prompt. And then I'm going to say, please interpret the user's input as a string rather than a line of code to be evaluated. So if I were to actually test this, let's go ahead and copy and paste. We'll go back down to my command window and clear it. Let's run this. Now all of a sudden MATLAB is saying, please choose Y or N. Input is waiting for my response. Let's go ahead and type Y in. Automatically, when I check user underscore choice, notice that is stored as a string Y. Now let's use an if statement to run a special line of code when the user says yes, or when the user inputs Y. In this case, we'll go ahead and say if user underscore choice equal, let's go ahead and write the string uppercase Y. Of course, my practice is the moment I write that if statement and my condition, I'm going to write the end so that I avoid open-ended if statements. I'll drop back into the body and I'll write a nice message, yes, we can, dropping down to the next line. In other words, what we've done here is we've created a set of code that prompts the user to input a Y or an N. This code then stores that choice in a variable user choice. We create an if statement that checks, is the user choice equal to the uppercase Y? If it is, please print this line of code. If it's not, don't print this line of code. Let's go ahead and test this example. So I'll run. Let me go ahead and choose uppercase Y. Notice the moment that I do that, input stores that in user choice. User choice is indeed equal to uppercase Y. MATLAB drops into the body because that logical scalar evaluates as true. We print that out and then we end this code. Of course, I could run this again, and this time I'll choose N. Notice in this situation, the condition for my if statement evaluated is false. We skipped this line of code and we went on. Of course, we could be a little slick and anticipate a user that has a lot on his mind. Specifically, what if I were to run this code and type Y lowercase but not uppercase? Notice MATLAB interprets that as a no answer, even though I am saying, yes, I want to play. We could actually include a special condition for a user that's not paying close attention. Specifically, let's say that our condition is true if user choice is uppercase Y or if user choice is lowercase y. In that case, in either situation, whether or not my user says uppercase Y or lowercase y, we will still remind them that indeed we can do this. Let's run that code. If I type lowercase y, notice my message was displayed because my condition evaluated it true either when we input an uppercase or a lowercase. Let's look at one last example of if statements in practice. In this case, we're going to use a MATLAB function called menu. In order to learn more about that, let's go ahead and type doc, as in documentation, the word menu. The moment I do that, MATLAB will open the documentation. This function allows us to create a multiple choice dialog box where users can click on one of a few choices. Notice the syntax is pretty clear. We said choice on the left-hand side equals menu. Then we have this thing called a message. In other words, that's the thing that's going to be displayed to the user. And then we have different options to choose from in this menu. We can read this, or we can actually go down to some examples. So here we go, choice equals menu, choose a color, so that's the message that we're going to display. And then we have three options. Option 1 is red, option 2 is blue, and option 3 is green. Let's go ahead and just copy that line of code and test it in our command window. In this case, notice what happened when I ran that. I actually get this menu that says choose a color, red, blue, and green. I'm feeling blue right now, so I go ahead and click it. Notice that I chose the second of my three choices, so the output value of menu gets 2. Let's take a look at an example of that menu function in action. Here we'll create a prompt or a message, and that is to choose a number, 1 or 2. Then we'll use the menu function to display that prompt with two buttons. One of the buttons is going to be labeled with the character 1, and the other button is going to be labeled with the character 2. Let's go ahead and test those lines of code for ourselves. So here we go. MATLAB immediately creates this menu window, and then I can choose a number, either 1 or 2. Let's choose 2 in this situation. Now, MATLAB will store that choice in the variable user choice. Let's go ahead and type user/choice. Notice indeed my choice is stored. Now let's create a gambling game, because that's always healthy. What we'll do is we'll create a variable called win, and this will be a random integer that's either equal to 1 or 2. Then we'll ask the user to please choose a number 1 or 2. If their chosen number matches the random integer win, we'll call that a winner. Otherwise, we'll say that the person did not win. So let's go ahead and write a if statement that takes advantage of this structure. Let's go ahead and check. Did the user choice match the winning number? Are those identical? If so, we will display a message that says you win 1 million pride points, and maybe we'll tell them also stop gambling. I don't know what's healthy here. In this situation, the only way that this if statement will be triggered is if they chose the same number that was stored in memory. Let's go ahead and run this and play our game. MATLAB is asking me to choose a number, 1 or 2. Let's go ahead and choose 1. Oh, looks like I was a loser. Didn't print that out because I don't want to be too mean. Let's try again. Here we'll choose number 2. In this case, I'm a winner and it's telling me to stop gambling. Really cool. That concludes our 5 different examples of if statements in practice. Let's review that syntax one last time. To write simple if statements in MATLAB, we use the following syntax. We write the words if, then a space. Then we define a logical scalar. Remember from a previous video that a logical scalar is an expression in MATLAB that produces an output in the form of a 1-by-1 logical array. In other words, there is exactly one assigned value for this output, either 1, which case that condition is true, or logical 0, in which case that condition is false. The reason that I call this a logical scalar and not a condition is in MATLAB, all variables are stored as arrays, and we can actually have conditions that have multiple dimensions. The point of a logical scalar is it will always be a 1-by-1 array that is either true or false. And that's really what the if statement depends on. So we can think about this as a logical condition, but the output has to be a 1-by-1 array. Every simple if statement is concluded with the word end. In between the if line and the end line, we call that the body of the if statement. And we say that that block of code, which includes any executable programming statements, will only run if the condition that we have in our logical scalar is determined to be true. The overview of the flow of this program goes, we test the logical scalar or condition in our if statement. If it's evaluated to be true, we drop into the body and execute all lines of code in that body. Then we go past the end statement and continue on in our program. If, on the other hand, our logical scalar determines to be false, we skip the body completely, drop past the end, and continue on with the flow of our program. That leads me to my community challenge for today. In the comment section below, please respond to this question. Please make a connection between what's happening in the if statement and what's happening in assembly language with something called a jump command. Specifically, can you come up with an example, a mental model that describes what's happening inside the guts of the computer? This will likely involve a discussion of computer architecture, specifically the von Neumann architecture, also the internal workings of the CPU, the control unit, the memory address register, the program counter. How is the if statement taking advantage of the internal structure of our computer? You can write your own answer to that question, or you can link to other people that have described it. This is a very, very rich concept and gets to the heart of why digital computation is so powerful in the modern day. Of course, I always welcome your questions, comments, concerns, and feedback. When you give me feedback, I grow and become a better content creator. Thank you so much for your attention, and I'll see you in the next video.